Alright guys and gals, we are back from Thanksgiving here, and we're back with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. And this is Unit 7, Day 1 notes. Unit 7, we're going to be finding a bunch of ways to solve for x. And today it's going to be by the square root method. First, we did the warm-up already. Just squaring numbers, making sure we know how to do our times tables. So let's go through these really quickly. Remember, when you're squaring a number, you're just multiplying that number by itself. So we have 2 times 2, which is?
4.
4. Okay. What is 3 times 3?
9.
Yes. What is 4 times 4?
16.
5 times 5?
25.
6 times 6?
36.
7 times 7?
49.
8 times 8?
64.
What about 9 times 9?
81.
10 times 10? 1. 11 times 11? 12 times 12? People's voices are dying out. 13 times 13?
169.
What about 14 times 14?
196.
196. And lastly, 15 times 15. Very good. There we go. Good. So that we're doing square root today. So we need to know how to square, and we need to know how to take the square root. So next we will be simplifying some square roots. These examples 1 and 2 are pretty easy because these are perfect squares. So you're going to get whole number answers. So on number 1, if you simplify the square root of 64, what is the square root of 64? Okay, but remember, when you take the square root of something, it gives you a number that would multiply by itself to get what you originally had, right? 8 times 8 is 64, right? Yeah. So that's right. But what else could you have besides positive 8? Negative 8, because negative 8 times negative 8 is 64. So both the positive and negative, and a lot of people always forget this, but this is something you need to make sure you keep track of every single time. Whenever you take the square root, it's always positive and negative. So on this next one, then example 2, what is the square root of 121?
11.
So as we just said, it's not just 11. Positive and negative 11, plus or minus 11. Okay? So every time you take a square root, make sure you put plus or minus. That's the biggest killer here, because there's always 2 answers. All right. So those ones are pretty easy because they're perfect squares. But what happens when you don't have a perfect square? You got to break them down and then leave them in radical form. You see this simplified square root of 20. Is 20 a perfect square? No. But can you think of 2 numbers that multiply to give you 20?
4 and 5.
All right, 4 and 5 are good because 4 is a perfect square, right? So this square root of 20 is actually going to be equal to square root of 4 times square root of 5. Right? Because 20 is 4 times 5. And that's very useful because what is the square root of 4? The square root of 4 is 2, but remember it's not just positive 2. What is it? Plus or minus 2, and then we just keep the square root of 5 because we can't actually simplify that. So my answer here would be plus or minus 2 square roots of 5. Okay, so on example 4, we're simplifying square root of 54. 54 is not a perfect square, but what are 2 numbers that can multiply to give you 54? 7 and 8 do not multiply for 54. That's 56. 6 and 9. So it's going to be square root of 9 times square root of 6. You were close. All right, square root of 9, and square root of 9 becomes what? Plus or minus 3. And then what do I also need to include? No, just square roots of 6. Just like this. Right, because square root of 54 is the square root of 9 times the square root of 6. But the square root of 9 is plus or minus 3. So we got plus or minus 3, square roots of 6 is the answer. All right, lastly, example number 5. This one looks a little strange because we have a negative number inside a square root symbol. Can you take a square root of a negative number?
No.
Yeah.
No, that doesn't actually work because, remember, something has to multiply by itself to give you a negative number. But that's impossible because you would think that the square root of 36 is 6, right? So that's right, but what's 6 times 6? 36. Positive 36, right. But what's negative 6 times negative 6? Positive 36 again. There's no way I can get negative 36, right? So for here, we actually have no answer. Later we're going to learn something that's going to just blow your mind. But for now, there's no answer. It's going to take a dive into your imagination. Okay. All right, so really quickly, so now we're going to be, the whole point of these notes is to show you how to solve using the square root method. So let me give you a little flashback. So last unit we did things like this, right? We had a quadratic equation, you know, x squared plus 5x plus 6 equals 0. You could find the two factors using the x box, right? You could get something like x plus 2 times x plus 3 equals 0. And then you could solve for x by writing two equations. You get x equals negative 2, x equals negative 3. You guys remember kind of doing this from last unit?
Yeah.
Okay, we got x. So if you worked out this problem, you would get x equals negative 2 and x equals negative 3. But what does that even mean? Because a lot of people didn't really understand what does that mean. What am I finding x's for? These x equals, that tells you where this graph crosses the x-axis. So if you take a look at this right here, this graph, boom. This is x squared plus 5x plus 6. And notice where it's crossing the x-axis. What are these locations? Negative 2 and negative 3, right? And that's exactly the answers that you would come across if you actually solved it with the x box. So today we're going to see another way that we can find those solutions, what x equals, but this is not using the x box. This is solving using the square root method. This is the easiest method to use. It's the quickest, but you can only use it on rare occasions. So you can only use it if you only have one variable term, and that variable term is a perfect square. So some examples of equations that work and don't work for square root method are listed below. See, like x squared equals 9. There's just one variable method. Are you raising your hand? X squared equals 9. You know, that works with the square root method. X squared minus 12 equals 37. That's actually going to work. All of these on the left are going to work. But on the right, we see x squared plus 5x equals 6. That's not going to work. And you have x squared equals 3x plus 4. And that's also not going to work. Can you guys recognize why those equations on the right side will not work for the square root method based on what it says right here? It has the x term, that's right. You're only allowed to have one variable term. It needs to be a perfect square. See, this x squared, that's a perfect square, right? So that's good. But then there's this random second variable term, and it's not even a perfect square, right? Because it's just x. These x terms make it to where you can't use the square root method. So in those cases, you would just have to use the x box method. All right, so this is what's messing up these two equations. So now we're going to solve using the square root method. Let's do some examples because practice makes perfect. So this first one, x squared equals 25. And look, they're telling you you're going to get two solutions, plus or minus. Okay, we're trying to solve for x, right? So how do I get x by itself on this very first one? X squared equals 20. We do what? You don't. You take the. You take the square root. The square root of. You said you square it. That's different. Square root is the opposite of squaring. Okay, so we take the square root. That cancels out the squared. So what's left on my left side? Just x on the left side. Equals. Right, positive or negative 5. Even in the instructions, they told you there's two solutions, positive or negative. So x equals positive or negative 5. Okay? Next, we have x squared equals 81. What do I do to get x by itself? Square root it. And that means your answer is going to be? X equals positive or negative 9. That's right. Make sure you write x equals. Very good. And what about the next one? X squared equals 16. What do I do to get x by itself? Square root it. That gives you? That's right. Okay, then the next one, x squared equals 50. What do I do to get the x by itself? Square root it, same thing, you square root it, but the only difference is here, 50 is not a perfect square. So we square root on the left side, we get x, right? On the right side, we get square root of 50, but what can I do with that square root of 50? 5 times 10, but that's not actually going to help us get anywhere. Can you think of two other numbers that multiply to give you 50? 25 times 2.
Oh, okay.
Because 25 is a perfect square. It's better to use that one, right? So this is going to be x equals square root of 25 times square root of 2. And what is the square root of 25? Positive or negative 5. That's right. So get used to keeping that positive or negative, okay? Because that's, remember, if you only give the positive version, you're giving me half of the answer. There's two solutions.
Why do you put 5 and then square root of 2?
Because it's square root of 25 times square root of 2. This 5 is only taking care of the square root of 25.
Oh,
But it's still being multiplied by square root of 2 at the end. So the answer should be plus or minus 5 square roots of 2. All right, on the next one, x squared equals 8. What do I need to do to get x by itself? Square root it. That gives me x equals the square root of 8, which is not a perfect square.
So 2 and 4?
So that's right, 4 and 2. So x equals square root of 4 times the square root of 2. And then what can I do from there?
X equals positive or negative 2
Right?
square root of 2.
That's correct. Good. X equals plus or minus 2 square roots of 2. And for this last one, x squared equals 12. What would I do to get x by itself? Square root it again, and then that gives me x equals square root of 12. And what can I break down square root of 12 into?
2 and 6?
2 and 6, but that neither of those actually 4 and 3, right? See, because 2 and 6 is not going to help me break it down any further, right? But 4 and 3, 4 is a perfect square. So we're going to break this down into square root of 4 times square root of 3. And so my final answer is going to be
Positive, no.
Positive, negative.
Yeah.
positive or negative
2.
2 square root of 3. That's right. Because the square root of 4 is positive or negative 2. And then we got times square root of 3. All right, so let's go to the back page now. These are some multi-step problems on the back page. More examples to solve using the square root method. So, the instructions tell you that you're using the square root method, so all of these problems you can solve using the square root. So, on x squared plus 3 equals 39, remember we're trying to get x by itself. What would you have to do first here? You can't do that because there's a plus 3 on it. So what do I do? Subtract the 3 first. That's right. Now that's going to leave you with x squared equals 36. Now what do I do from here to get x by itself? Square root. And so x equals positive or negative 6. Very good. On the next example, we got 3x squared plus 4 equals 64. What do I need to do there first? Subtract the 4, that's right.
Give you 60.
Okay, so 60 on the right side, and the left side is
3x squared.
3x squared equals 60. Divide by 3, that's right. And so that gives me equals 20. And now what do I do from here? Square root it. And that would give me
X equals
square root of 20. What can I do with that 20?
5 times.
10 times 2 doesn't break it down at all. 5 times 4, that's right. So x equals square root of 4 times square root of 5.
And then x equals positive or negative 2 square root of 5.
That's correct. X equals positive or negative 2 square roots of 5. Very good. All right, on to this next example down here. 2 times x minus 1 quantity squared equals 20. So remember, we're trying to get x by itself, so we got to take out all the extra stuff first. So what should I do first there?
Distribute.
There's no distributing. Remember, this is 2 times x minus 1 quantity squared equals 20. How do I get rid of times something? Divide. So what should I divide by? 2. So we just divide by 2, and then boom, look, that 2 is gone. So now what am I left with? X minus 1 squared equals 10. Now from here, what do I do? So notice it's x minus 1, and that's trapped inside by the squared. So how do I get rid of the squared? Square root. To get rid of the squared, right? So to get rid of the squared, I just take the square root. So that's going to cancel out the squared. So what's left on the left side now? X minus 1 equals square root of 10. But the square root of 10 is not going to break down anymore, right? So right away here, whenever I take the square root, it should be positive or negative. So we can just put positive or negative square root of 10.
Is that the answer?
Not yet, because we got to get x by itself. So what do I need to do to get x by itself? Plus 1. And so when I add 1, that's going to give me x equals, and you can't combine the 1 with the number that's under the radical, so you just leave it separate. So it's just going to be 1 plus or minus square roots of 10. And that's actually 2 solutions, because one of the solutions is 1 plus square root of 10, and the other solution is 1 minus the square root of 10. See that? Okay, on to the next example then. What would I do first on this one? 3 times x plus 5 squared minus 4 equals 23. Add 4 first, that's right. I add 4, and that leaves me with 3 times x plus 5 squared equals 27. What do I need to do after that? Divide by 3, that's right. We want to get that 3 out of there. After I divide by 3, then I get?
X plus 5 squared equals 9.
That's right. X plus 5 squared equals 9. Now what am I going to do? Square root to get rid of the squared. After I take the square root and that cancels out the squared, what am I left with?
X plus 5 equals plus or negative 3.
That's right. X plus 5 equals plus or minus 3. Move that up here. And now what do I need to do to get x by itself? Subtract 5. And so my answer is going to be? That's right. X equals negative 5 plus or minus 3. But if you stop here, you're going to only get parts of the credit, because that's not a complete answer. These are whole numbers, right? So I can actually write the answers here, because that right there, it tells me there's 2 answers. One of the answers is x equals negative 5 plus 3. The other one should be negative 5 minus 3, right? So I want to write those 2 answers out. X equals negative 5 plus 3. What is negative 5 plus 3? Negative 2. So one of my answers is x equals negative 2. So for my other answer, it's going to be x equals negative 5 minus 3. Okay, so what is negative 5 minus 3? Negative 8. And so those are my 2 answers. Because right here, you see where it says x equals negative 5 plus or minus 3, right? That's just 2 whole numbers, so we want to just break it down into 2 separate equations, right? On the previous example, we had 1 plus or minus square root of 10. But square root of 10 is not, like, it's not a whole number. We don't even know what that equals, so we just leave it like that. But on the ones where we do have whole numbers, you got to actually work it out and give me those 2 numbers, right? Just like, on a test, you're not going to write like 10 minus 27 and leave that as your answer. I'm not going to work that out for you. No, you got to do that yourself. So just like right there, you got whole numbers, work it out and write your final answer. Yeah, x equals negative 2 and x equals negative 8. All right, the next example, we got 2x squared equals 200. What will we have to do here first?
Divide by 2.
Divide by 2. That leaves you with,
100? No.
all right, x squared equals 100, and then square root. So my final answer is x equals plus or minus 10. Don't forget to write the x equals, okay? That's the whole point. Telling me what does x equal? Where does it cross the x-axis? All right, last example right here. 2 times x minus 4 squared plus 12 equals 30. What do I do first? Subtract 12. Subtract 12, and that leaves me with
2
equals 18. Very good.
Then divide by 2.
Then divide by 2, right?
And then
X,
squared.
it's x minus 4.
Oh, x minus 4.
Squared equals 9. Okay, we got x minus 4 squared equals 9. What do I do here? Square root to get rid of the squared. X minus 4 equals plus or minus 3. Very good. And then add 4. Okay, can I leave my answer like that? No. What do I need to do? Right? Which is? That's right. So one of my answers is x equals 7. Very good. And now for my other answer? Yes, so x equals? Very good. Nice. That's perfect. So those are my 2 answers. You're always supposed to get 2 answers, okay? Sometimes, you know, they'll be the same, exact same number, but that's okay. You should get 2 answers all the time. There we go. So now you can see on the works and doesn't work, you know, we're able to solve these, right? But you can't solve the ones using the square root method where there's just the x term right there. Okay, so also you guys need to remember how to solve by factoring. That's using the x box. So do you guys want to see an example of that, or do you think you got it? Example. So let's just do number 2 then, okay? All right, so you need to, well, let's do 3. 3 is going to be a good representation of why we would use square root method. So number 3, do you guys recognize that we could actually use the square root method there? Like what we just did, we could do right there on number 3, right? Because you just see one term, it's squared, and then equals a number, right? But you can also use the Xbox method, which is what we originally learned. And this is going to really show you why, if you understand the square root method, it's a lot faster. Because if I just did the square root method, I would just divide by 6, right? I get x squared equals 9, take the square root, and x equals plus or minus 3. So I already know my answer should be plus or minus 3, right? That was quick with the square root method, but look, now I'm going to show you the Xbox method because that's what this asks for.
Do we always have to do the Xbox?
If it tells you to solve by factoring, you got to do that, right? But anyways, what would I have to do first here if it was going to be the Xbox method? This is just to refresh your memory about the Xbox method.
The A, B, C.
Before that, though, there's always 2 things you got to do. Right, you got to set it equal to 0 by doing what? Subtract 54. And so that would give you
6x squared minus 54.
equals 0. Good. So that's the first step. Remember, always set it equal to 0. What was the second step? Do you remember? You check for greatest common factor. Is there a greatest common factor between these 2 terms?
Yes.
What? 6. That's right. I can factor a 6 out of both of those terms. So what is left after I factor a 6 out of both of the terms? X squared minus 9 equals 0. Good. Now after you've done the GCF, now you're ready to use Xbox. This is where you go A, B, and C. So what is A?
6.
It's only on the inside of the parentheses, remember? A is in front of x squared, so what is it? It's 1. The number in front of x squared, right in front of it, not outside the parentheses. Outside the parentheses, the whole point of factoring that out was so we don't have to worry about it. So A is 1. What is B?
0.
0. We don't see an x term, right? There's no just x there. So it's going to be 0. And what is c, though?
Negative 9.
-9. There we go. 1, 0, and -9. So now we draw the x box. What goes in the top space?
Negative 9.
How did you get that, though?
Because 1 times negative 9
A times c is -9, right? And what goes in the bottom space?
B,
Which is
0.
0. So now the only way for me to add two numbers and it equals 0 is if it's the same number and one's positive, one's negative. So what should the numbers be? Positive 3 and -3. So that's what goes in the side. And what do I do after I find those side numbers?
Divide by your A.
You put the divisions, right, the fraction line, and then on top it goes
1x.
ax, which is 1x. And remember, you're supposed to simplify the fractions as much as possible, but because there's a 1 on top, it's already the most reduced form, right? So those are our factors. So what is my factored form then?
X plus 3 and then x minus 3.
Hang on a second. Let's see. We got, you said x plus 3? That's right. And then x
Minus 3.
minus 3. However, what are you forgetting though?
Your c equal to x. Yeah.
That's right. It's the 6. So you guys are right in solving, but remember, if I'm just factoring, exactly, this 6 needs to come down. It can't just disappear. Okay? You know, that's like, you know, $100 is the same thing as 2 times $50, right? But what if I just gave you $50? You'd be like, what the heck? No, give me that 2 times $50, you know? So that's the same idea. You got to bring down that 6. It's not fair to just leave it out. Okay, and then as you guys were saying, to solve for x, what do I have to do?
Bring it out of parentheses.
And then do what?
X plus 3 equals
x plus 3 equals 0,
0.
and the other one would be?
X minus 3 equals 0.
Right, and so what would I do to solve for x then?
Subtract 3 and it gives you x equals -3.
Right?
And then x equals positive 3.
Right, for this other one, add 3, x equals 3, like this. And you can see our answers are x equals 3 and x equals -3, which was that exact same answer that I showed you a second ago, x equals plus or minus 3, right? Using the square root method. But notice this takes a lot more work, doesn't it not? Doesn't it? Yes, it does. Yes, it does. But yeah, that's it. Okay, so until the next time, I'll see you then. Peace!